Hello again, this is Mrs. Taylor back with you, and we are going to be looking at velocity versus time graphs in this video. And so we're going to start with that same process of labeling our axes. This time we have a little different axis. You'll notice that we have both like a top half and a bottom half. If you want to do mathy speak, that's like first and fourth quadrant. But if you don't want to do mathy speak, that's okay. So we're going to label our x-axis with time. And then we'll label our y-axis with velocity. And I should have taken a little pause. If you haven't looked at this yet, you want to pause and stop and try some of this stuff on your own before you dive in with me. So if you haven't done that, pause right now and do that, because you do need to have read and thought about this prior to us jumping in together. All right, so I'm on step 2. It says label zero velocity, okay? And now we have a trick question here. Is this the origin? And you're going to hear me shout a big no. It is not an origin. That 0 right there represents a 0 velocity. It means an object that is stopped. It is not moving. It does not tell you where in the world Carmen Sandiego is. And I know you don't understand that reference, but that does not tell you where the object is. It just tells you the object isn't moving, because this is a velocity graph. This is not a position graph. That's a distinct difference. Okay, so we're going to start sketching a velocity graph that is positive and constant as time increases. So this means that we're going to have a positive and constant velocity graph. Okay, this object we know is moving away from the origin. We know that because if I pop up here and sketch a little position graph, right, this is from our last video, the corresponding position graph might look something like this. We have a positive constant velocity moving away from the origin at a constant speed produces a velocity graph that looks like what you see there. All right, we're going to get rid of that. And then it says circle the top half of the velocity graph and label it with the correct label. So this right here, anything on the top half of the velocity graph means the velocity is positive. And that means that that object is moving away from the origin. Okay. For an object at a constant velocity, the velocity graph is a horizontal line. That means that the velocity doesn't change over time. Okay. So then the next part asks us to sketch a velocity graph for an object that's moving toward the origin, moving at a constant speed. Right, so we're going to draw that. That's going to be on that bottom half. So this is toward the origin at constant speed. Right? This whole bottom half of the velocity graph means that the object is moving toward the origin. The slope of the position graph for this object, if I were to pop down here and draw it quick, right? We drew this last time. Might look something like this. The slope of that position graph is going to be negative because the object is moving closer to the 0 position, i.e. the origin. That causes that velocity graph to be negative. All right, so now we're going to start talking about velocity graphs that the velocity is changing. So they're a little bit tricky, but if you really think back to top half, bottom half on a velocity graph, that's going to simplify your thinking considerably. Okay, so we're looking now at our velocity graph. We're going to label them again. Now notice it just has you label both of them at the same time because, hey, why not, right? Let's just get that all done. I really wish that little thinking would go away. That would be helpful, I think. Meters per second, if you were having a hard time reading my writing, that is meters per second. And then my x-axis is time in seconds. And we're labeling the 0 velocity on both of those. All right, so take a moment and I want you to look at the title above the graphs. Notice the top graphs are all for objects that are speeding up. They're getting faster and faster and faster. All right, so we're going to start on the velocity graph, and on number 2 here, it says for an object speeding up, moving away from the origin. So if we're moving away from the origin, we know on the velocity graph we're on the top half. So we're going to be working somewhere up here, right? We're going to be working somewhere up here. And we are going to be speeding up. So that means over time, our velocity is going to get further away from zero. So as time goes up, our velocity is going to get further away from zero. So that means that my graph, my velocity graph, is going to look something like this. So this is speeding up away from the origin. All right, so notice I just have to label this guy away because I already got my speeding up here, right? Speeding up, moving away from the origin. So then 4 asks us, or 3, excuse me, asks us to draw the velocity graph for an object speeding up and moving toward the origin. Okay, so if I'm toward the origin, I know that has to be on the bottom half of my velocity graph. I got to be down here somewhere. But remember, over time, my velocity has to get further and further away from zero. So as time goes up, but my velocity has to go up too, but it's got to be getting more and more negative, right? It's getting further away from the zero velocity. It's getting faster and faster as time goes on. So that means that my velocity graph might look something like this. So this is the velocity graph for an object moving toward the origin, speeding up. Right? So notice that both of those graphs, as time goes on, both of those graphs get further and further from zero velocity. That's what question 4 is getting at. How does a velocity graph show the object is speeding up, meaning velocity is increasing as time increases? And that means that the velocity moves away from zero. Okay. What is this again? This is zero velocity, meaning it's stopped. It's not moving. Okay, so now we're ready to start talking about slowing down, which is probably a good thing because sometimes I get going too fast and we all just need to slow down a little bit. All right, so we've already labeled yay, rah, rah. Now we need to draw the velocity graph for an object that's slowing down but moving away from the origin. Okay, so translate. Away, top half of velocity graph, but slowing down. That means the velocity has to get closer to zero as time increases. So our velocity is going to get closer to zero as time increases. This is slowing down but moving away from origin. And you might say, wait, Mrs. T, how is that moving away from the origin? Look, the line goes to zero. What's that zero mean again? Is that zero the origin? No, that zero is not the origin. Remember that zero velocity. On a velocity graph, when a line is getting closer to zero, that means that the object is slowing down. Doesn't mean it's getting closer to the origin. It means it's getting closer to zero velocity. All right? So let's go ahead and write slowing down just to make sure we're like super clear. Slowing down, moving away from origin. All right. So now we're ready for number 3, which is on the velocity graph, drawn a graph of the object that is slowing down, moving toward the origin. Okay, toward the origin means bottom half. So we're on the bottom half, but it's got to slow down. So that means my line, again, my velocity has to decrease over time, which is a little confusing, right? It's getting less and less over time. That velocity is getting closer to zero. Remember, bottom half means we're moving toward the origin, and this is slowing down. So then number 4 says, how does each velocity graph show the object is slowing down, meaning the velocity is decreasing as time decreases? And that means that the velocity value gets closer to zero. And when I mean value, I mean like right here, like let's look at like this time right here, look at its value. And then we look at this time right here. See how that is getting closer to zero? So as time goes on, that velocity is becoming less and less over time. So that's it for our velocity versus time graph. If you need an explanation for any of those, go back and listen to different parts of that video. hopefully those explanations are in there. And the next video will give you some insight into the relationship between velocity and acceleration. Thanks for listening.